So recently Andreas asked me, how much time do you need to make a game? Feeling a bit bold, I confidently said 10 minutes. I mean, it's not like he would have any way of finding out. Of course, he responded with, great, let's make a video on that. After which my confidence was gone. But I've now have time to adjust to the idea and think it sounds really fun. Also, doing game challenges like this is always a great way to practice. I'm gonna try and replicate Super Hexagon, which is a really cool mobile game. So, without any more introduction, let's make a game in 10 minutes. Alright, so all the cameras are rolling. There are so many cameras here. There's one there, one there, one there, and there's even one up there. So it's pretty exciting. And I think we're all ready. So let's just start the timer and let's get started. So the first thing that we want to do here is probably just sketch out our level. So I'm just going to select my main camera and I'm going to give it some kind of fairly vibrant red color. I think this looks pretty good. You can always play around with this later. I'm also going to go ahead and create a 2D sprite. And for the sprite here, I'm going to select a knob. I'm also going to reset the transform and set the scale to something like 3.8 by 3.8. I'm also going to set the color to black and make it transparent. And this is just going to mark the center of our screen. Let's then go to the object sprite and create all players. So let's rename this to player. Again, reset the transform on this. And for the sprite, let's also just choose the knob here. We are on a limited time. Let's set the Y to 0.6 to move him up. And now we can have him rotate around the knob. Of course, in order to do that, we need a few components. We first of all need a rigid body 2D that we're going to mark as kinematic because we only want to move it through script and not by forces. Let's also create a circle collider 2D and mark it as a trigger because we don't want collision, we just want to know when he collides with something. And let's then also create a player script, and this is of course what is going to move around our player. So let's double click this to open it up in Visual Studio and hope that Visual Studio opens quickly today, please. Wasting valuable time. All right, so let's get rid of our start function here and instead let's create a public float. And since we're going to be moving our player, we of course want to know how fast. So let's create a move speed by, let's say, 600 by default. Then inside of our update method, we can get some input using getAxis raw because we don't want any input smoothing here. And I'm going to get the horizontal axis, so that is the A and D keys or left and right on the keyboard. Let's actually store this in a variable because we don't want to do the movement itself inside of update. So let's do movement equals 0 and let's set it equal to our input. And now we can create a separate fixed update method where it's much better to do our input. We can use transform.rotate around, and this is a pretty cool method because it allows us to rotate around a certain point. And I want to rotate around the center of our screen, our knob, so vector 3.0, and the axis is going to be vector 3.forward, the set axis, and the angle is going to depend on our movement multiplied with time.fixed delta time multiplied with our move speed. And I believe that we need to reverse this, so I'm going to put a minus here, but I might be wrong. So let's save that, head into Unity and hit play, and hopefully, yes, we can move around our player. That's good. Player movement done. Yay! So the next thing that we need to do is, of course, add in a hexagon so that we have stuff to avoid. And we could do this by opening up Photoshop and quickly creating a sprite, but that would mean that when we scale the hexagon, the width of the line would scale as well. So instead, let's create a line renderer here, and I'm just going to reset the transform on this. And inside of the positions array, we can now start to use a line. Let's set the C to 0. We always wanted that to be 0, but you can see here that we can now create this line. And I'm going to try and approximate a hexagon using this method. So a hexagon has 6 positions or 6 points and 6 sides. And the first one is going to be something like -0.5 by -0.8, just 0.8. Let's do 0.8. And then the second one here is going to be -0.95. Ooh, 0.95. Don't have time for errors. By 0. You could also just do 1, but I think this is going to be better because it's not a round number if I have my math right, which is very much in my head right now. 0.8, 0.5. Oh, this is stressful to do. -0.8 again. Yes, it's looking like something. 0.95 now and 0. And finally, it's going to be 0.5 and -0.8. No, just 0.8. 0.8. Yeah, all right, that actually looks like a hexagon. Might want to bring in the sides a bit more. It's just an approximation, bear with me guys. So we now have a hexagon, and the cool thing is that when we scale this, the line thickness remains the same. So we can go in here and set the width to something like 0.2, and it's always going to look cool. Awesome. We then name it something like hexagon, And of course, we need a few things on this. First of all, we need a collider. So let's go in here and create another object. I'm going to put this on a separate object so that we can mess with it. And you'll see why in a sec. And let's do an edge collider 2D. And we want this to have all the same points. We want it to follow the shape. So let's go ahead and lock this layer. And let's go and add another inspector. Not lock the layer. Whoa, I had too many inspectors in here now. So we have 2 inspectors now, and we can select the hexagon because this one is locked, and we can go into the line render, and now we can see all the positions and simply copy them in. Really cool. So I'm just going to do this quickly because I don't think I can do this while talking. All right, I think that's right. So we can now close this inspector here and also unlock this inspector here. And now we should see that when we select our collider, there's indeed a green line that goes around. And the cool thing is, because it's on a separate layer, we can simply scale it in a bit, and it's now on the inside only of our hexagon, which is where we want to register collision. So that's perfect. And now on our hexagon, we can go ahead and create a few components. We want a rigid body 2D. Again, this is going to be kinematic. And let's also create a hexagon script. Cool. And yes, I do want to open that, but please open it correctly. There we go. Awesome. So inside of our hexagon script, we of course need a reference to our rigid body. So let's create a public rigid body 2D and let's call it RB. We also need to define some kind of shrink speed. So let's do float shrink speed equals 3. And then inside of our start method, we can start by setting a random rotation for our rigid body. So we can do rotation equals random.range between 0 and 360 degrees. And we can also set our scale, transform.not local angles, local scale, equal to vector3.1 multiplied with some large number. Let's just do 10. Hopefully that works out. Then inside of our update method, we need to always shrink it. So local, again, local scale, please. Minus equals vector3.1 multiplied with shrink speed multiplied with time.delta time. I think that's going to work. And then we can check that if our transform.local scale, we can use any coordinate, I'm just going to use x, gets below 0.05, we probably want to remove it. So destroy game object. All right, I think that's going to work. So if we now go in and we need to remember to link up our rigid body. I was about to forget that. So link up the rigid body here, hit play, we should see that our hexagon becomes really big and then slowly shrinks and then disappears. Awesome, it works. So we can now take our hexagon and move it down here in order to create a prefab out of it. And of course we need to now spawn in some hexagons. So we'll create some kind of spawner. Let's just call it spawner. And we'll also create a component called spawner and spawner, open this up, spawner, there we go. And this is actually fairly simple. We need to create some kind of spawn rate. So public float spawn rate equals 1. And we'll also need to create a public game object, hexagon prefab, and a public float, private float. Doesn't really matter, but it does. Next time to spawn. So this marks the next time that we want to spawn in a hexagon. And then inside of our update method, we can check that if time, so our current time is greater than the next time to spawn, well, then we want to go ahead and spawn in a hexagon. So we'll instantiate a hexagon prefab at the center of our world, vector 3.0 with no rotation, so quaternion.identity. And we also want to set the next time to spawn equal to time.time, our current time, plus 1 divided by our spawn rate. Awesome. I think that should work. Again, no guarantees when doing things this fast. Oh, no, I hit play. Yeah, that's an error because we need to link our hexagon prefab. Oh my god, so stressful. And let's hit play. And now it spawns in hexagons. Amazing. Of course, nothing happens when we actually collide with them. So to fix that, let's go into our player script. Let's add a quick method here, and this is just going to be a void on trigger enter 2D. So when something enters our trigger, let's restart our level. In order to restart our level, we need to be using Unity engine dot scene management. There we go. And then down here we can go scene manager dot load scene, and we want to reload the currently active scene. So scene manager dot get active scene dot build index. And there we go. We can also print some kind of message or slow the game down or show some kind of game over. But for now, we'll just restart it. So now we should see that if we hit the side here, Yes, it restarts. I'm so happy that worked. And the final thing that Super Hexagon does, I think we have time for this, I have no idea. The final thing that Super Hexagon does is that it kind of rotates the camera constantly in order to give this pretty cool, nauseating, confusing, but cool effect. And to do this fairly easily is just add a script on our main camera called something like rotator, not roator, rotator. And if we open this up inside of our update method, we simply want to do transform.rotate by vector3.forward, again, around the Z axis. And our rotation should be time.delta time multiplied with some speed. I'm going to go 30. And again, I want this to move in a I don't remember, in the opposite direction, I believe. Just going from the hunch, and I think that should be it. So now when we play this, yes, our camera is constantly rotating, and we now have a game. That's it. We did it. That's Super Hexagon. Not quite. It's not Super Hexagon. It's an amazing game, and it takes more than this. But we have something, and I believe it's within the time frame. Someone tell me. That's amazing. So hopefully you guys like this sort of format. I think it's really fun to be challenged and to do something that you won't usually do. It's always fun to make a game where you don't get caught up in how pretty the code is or optimization and all these bigger thoughts and just adding lots and lots of features. Sometimes it's fun to just sit down and do a game really quickly, and hopefully, I don't know what camera to speak to here, but hopefully you guys kind of will try this out yourselves. So I am now challenging you guys to do this yourselves. That's right. I want you to grab your mouse and keyboard and try to make a game in 10 minutes. And if you want to be a super badass, you can even film it and share the video and game on Discord. We've gone ahead and created a channel specifically for the 10-minute game challenge. Of course, I completely understand that creating a game in 10 minutes might seem really scary and hard. And it is. But it's also a really great way to improve and force yourself to just make something. After all, who cares how good the end result is? You only had 10 minutes. Also, make sure to let everyone know that you're participating by tweeting with the hashtag 10minute-game. And I would actually like to challenge Sam Saiku specifically to do this challenge. Also, if you don't already know Sam's channel, you should definitely check him out. Also, make sure to leave a comment to help encourage him. Other than that, I wish you the best of luck with the 10-minute game challenge, and I really look forward to seeing your submission. Thanks for watching, and I will see you in the next video. Thanks to all of the awesome Patreon supporters who donated in September, and a special thanks to Andrew Kalinenko, Art Armin, TrueVR Systems, Simmer.io, Alexander Blair, Cheetah3D, Jeff Johnson, Infinity PBR, Cyborg Mummy, Dennis Sullivan, Chris, Sheriff Abdullah, Faisal Marify, Fang Sulong, Leo Lassette, Clinton Van Skewer, Swears D, Derek Heemskirk, Ronan, Tim of Holderbach, Bruins Cat, Naoki Iwasaki, Gregory Pierce, Larry Tweed, James Rogers, Rob Farron, Pacom Bernier, Erasmus, Robert Bund, Corey Jackson, James P., Anthony Patton, Kyo Sweeteski, and Obrisi. You guys rock.